Okay, so now let's continue with longitudinal data analysis for a binary outcome variable. That means longitudinal data analysis for a logistic regression. And here we do have a data set having a categorical outcome variable, which is depression cut. That means the depression score have been categorized into two binary outcomes. A depression score of above 10 Edinburgh postnatal scale as positive for depression and less than 10 as negative for depression. So 0 for no, yes for 1. So compared the 0 will be a reference, for the outcome variable. And we do have again the depression score, the continuous. Now this continuous could not be used as an outcome over here. The visit is the time, the pre is again the similar variables that we have seen previously, the group is the treatment group, So as usual, click on be aware that the data is in the long form again. The data is in the long form. So now let's proceed to do this longitudinal data analysis for binary outcome. Click on Analyze and go to Generalized Linear Models and then Generalized Estimating Equation, Okay, so here the subject ID will be there in the subject variable, and maybe we can try each of the working correlation structures one by one as we did in the previous example. But for this case, let me just use this autoregressive working correlation coefficient. And then the type of model here is it should be a binary logistic, binary logistic. So I do have a binary logistic over here. So click over this binary logistic. And the response variable is now categorical variable. So I need to take this deep category to the depression outcome, to the outcome, and then reference category should be chosen over here. Highest value, lowest value. Okay, the lowest value, that is 0, will be a reference. Okay, continue. And then predictor variables, I need to take this group to the factor box, and this the descending will be the group placebo. I think 0 was placebo, should be reference. And then the continuous predictor variables pre and visit will be taken to the covariate box, And then clicking on the model, I need to take all these predictor variables to the model and check that this main effect is already selected. And the estimation, we are not going to do anything there, but in the statistics, we need to take this or check this include exponential parameter estimate because we want the odds ratio. And if you want to see the correlation matrix, click over here, working correlation matrix, to display the working correlation matrix, So hereafter, click on OK. So here is the generalized linear model information that is similar as we have seen in the previous example, Here the model information. Now, dependent variable is depression categorical, and the probability distribution is binomial, and the link function is logit now because we have used the binary logistic regression for longitudinal data analysis, So the probability distribution and the link function will be binomial and logit. Okay, the working correlation structure is autoregressive that we have selected. Here's processing those who are included and excluded. Those excluded are with the missing value. Okay, categorical data or variable information for the outcome dependent variable, yes and no, with the number and percentage. For the predictor categorical variable, estrogen and placebo, frequency and percentage. For the continuous variable information, especially for the the pre-trial depression score, and for the time or the visit, the frequencies, the minimum, maximum, mean, and standard deviation has been given. If you are going to use this QYC value, you can have a look at over here. But we are relying on the p-value of each working correlation structure, So the test of model effects will tell us whether each predictor variable are statistically significantly associated with the development of the outcome variable over the follow-up period. So you can have a look at over here. The group variable, the pre-variable, and the visit variable all are statistically significantly associated with the development of depression in the follow-up period, you know. So here is a parameter estimate that you can interpret in the similar way with interpretation of the logistic regression. So each of the predictor variables having the beta coefficient, so some of them are negative and positive with the odds ratio, exponent of beta, and again with the p-value, which are significant, you know. So the similar interpretation will be applicable here. So for example, compared to those women in the placebo group, women in the treatment or in the taking the drug are 0.218 less likely to develop depression in the follow-up period. And you can express it in the percentage also. You can subtract this odds ratio from 1 to 21.8. Okay, now it will be around 79.2, maybe. No, 78.2, around, yeah, 78.2% reduction in risk of developing depression, you know. And the pre-visit, with a unit increase in the pre-trial depression score, the probability of developing depression in the follow-up period will increase by 1.146 times, you know. And the visit with a 1 month increase or with a 1 unit increase in the follow-up period, the probability of developing depression will decrease by 0.653 times. So that is the interpretation, you know. And you can have a look at on the working correlation matrix. Since we have selected the autoregressive working correlation structure, the correlation coefficients will decrease as time goes on. And you can have a look at over here. So this is the way how we can do a longitudinal data analysis for binary logistic regression, you know. So this similar approach will apply for all other types of outcome variables, whether survival, categorical, ordinal, multinomial, whatever. So this is all about longitudinal data analysis.